Okay, so in this third session of summer school, we're going to be advancing your skills further. You're going to start by creating this screwdriver on here. It's a good video to get some experience or some more experience of dealing with components. And once you've done that, we're going to do some work on looking at this toolbar at the bottom. Okay, so this toolbar at the bottom, which you can't really see that well because of the instructions down there, is a good way of actually learning how something has been made. And there's lots of different things you can actually do with that toolbar that I didn't actually know before I watched some of these videos. Okay, so this is the third and last video in the series of summer school, which I hope has been beneficial and pointed you in the right direction to hopefully advance your Fusion skills a little bit further. Okay, now I've been using Fusion for about 4 years, and I probably know about 30% of what some of the capabilities it can do. The other thing that it's taught me, just watching these videos and this guy online, this product design online guy, it's taught me different quicker ways of doing things as well. So I want you to have a go. The first thing you're going to do is create the screwdriver. Then the following video, we'll use that screwdriver to teach you a little bit more about using this for shortcuts and which will be really useful in the future. The whole point of this summer school is to hopefully get you ready for the next stage of the project, which will be the CAD and development stage. Okay, so I hope you've enjoyed them. If you want to have a look at some more, if you go into product design online and learn Fusion every day, and try and have a go at some of the other videos and advance your skills even further.
We're going to start off by modeling the handle of the screwdriver as one component, and then we'll create a second component for the shank of the screwdriver. To create a new component, I'll select New Component from the Assemble drop-down list, and I'll double-check that Empty Component is selected. Before we hit OK, we'll follow rule number 2 of Fusion 360, which is to always name your bodies and components. I'll type in Handle for the name, make sure Activate is selected so we can start working on the component right away, and I'll click OK in the New Component dialog box. Now let's start to create the handle by using the cylinder tool from the Create drop-down list. After selecting cylinder, I'll click on the front face, click on the center origin, drag out with my mouse, and then I'll type in 28 millimeters for the width. I'll hit the Tab key to lock the dimension in place, and I'll click with my mouse to snap the circle in place. Then I'll make the length 100 millimeters and click OK to exit the cylinder feature. And before we do anything else, I'll rename the body Cylinder by double-clicking on it in the Fusion 360 browser, and I'll type out Cylinder. I'll also click on the Save icon, type out Slot Head Screwdriver for the name, and I'll click the blue Save button. At this point, we could leave a basic cylinder shape for the handle, but it would work better and be more ergonomic if we cut some grooves in it. To do this, I'll look at the handle from the back side. Then I'll hit the keyboard shortcut letter C for center circle, and I'll click on the back face of the handle. What I want to do here is draw a circle, extrude cut it, and then I'll pattern the cut feature around the handle. So I'll just click on the left side here at the edge of the handle where the center circle function will snap into place. And I'll make this circle 6 millimeters. Now I'll hit the keyboard shortcut letter E for extrude, and I'll extrude cut this 75 millimeters, and then I'll click OK to exit the extrude command. I'll activate the circular pattern feature located in the pattern folder under the Create drop-down menu. You'll see that after we activate the pattern feature, we can select the pattern type. I'll select Features as the pattern type, and then I'll select the Extrude feature in the timeline below. For the axis, I'll select the center axis of our handle. And remember, if you ever can't select the axis here in the canvas because it's blocked by a body, you can select the axis in the Fusion 360 browser. Now we want this pattern to go all the way around the handle, so I'll make sure full is selected as the type, and then we'll set 6 for the quantity or the number of times to pattern. Looking at the model, we can see a faint preview of the pattern, but let's go ahead and click OK to see the results. Now, one thing to note here, we could have used the sketch circular pattern and patterned the circle around before we extruded it, but I recommend using the pattern feature under the Create drop-down list when possible, as it will perform much better in Fusion 360, especially when dealing with larger and more complex patterns and assemblies. Now, the main reason is because the sketch tool is trying to render all of the geometry, whereas if you look at the sketch of our pattern feature, it's simply rendering the one circle, and the pattern feature is mimicking the extrude cut. At this point, I want to add a nice fillet or rounded edge to the back of the handle. I'll select the keyboard shortcut letter F to activate the fillet command. I'll select all 6 of the outside edges, and I'll type in 10 millimeters for the distance. And of course, you can always type in more or less here. It really just depends on how much you want the back of the handle to be rounded over. We'll click OK to exit the fillet command. Now, I'll want to add a rounded divot to the front of the screwdriver so our thumb and forefinger have a nice and ergonomic place to rest. I'll right-click on the YZ plane in the Fusion 360 browser, and I'll select Create Sketch. We're going to use this center plane because we're going to draw an ellipse, and then we'll revolve it around the cylinder. I'll select the ellipse tool from the Sketch drop-down list, and I'll click just above the handle. Now, I'm not sure exactly how far down I want to go, so I'll just go down 6 millimeters, and I'll go to the right about 21 millimeters, as we can always go back and change the dimensions. Now I'll select the Revolve tool from the Create drop-down list. I'll select the ellipse we just created as the profile, and once again, we'll select the center axis of our handle. I'll make sure that my operation is set to cut, and I'll click OK to see the results. Now, looking at this divot, I may decide that I want to go down a bit further. If so, I'll double click on the sketch and the timeline to edit the ellipse, and I'll change the height here to 8 millimeters. I'll hit Stop Sketch and take a look at the new results. Alrighty, so our handle is coming along nicely so far. The last thing we'll want to do is add some nice fillets or rounded edges to it. And then we'll proceed on to make the shank and tip of the screwdriver. I'll hit the keyboard shortcut letter F to activate the fillet command, and I'll select the front circle of the screwdriver. I'll add a fillet of 1.5 millimeters and click OK. I'll hit letter F again, and I'll select these circles on each end of our divot, and I'll make these 1 millimeter and click OK. Lastly, we'll go ahead and add some nice rounded edges to our grips here. Clicking letter F to activate the fillet command, I'll select all 6 of the grip edges, and then I'll punch in 2.5 millimeters for the fillet distance. I'll click OK, and then I'll right click on the edge here, and I'll select Repeat Fillet. I'll select all 6 of these corresponding edges. I'll make this edge rounded off with 1 millimeter, and then I'll click OK. Now, the last thing we'll want to do with our handle before we're done with the component is to add a hole for our screwdriver's shank. I'll hit the keyboard shortcut letter H for hole, and I'll click on the front face of our handle. Now, the hole should have snapped to the center origin. You'll see if I drag this hole around, it will snap right into that center origin point. We want our hole to go halfway into the handle. In the hole dialog box, I'll make the length 50 millimeters. I'll make the width of the hole 7 millimeters, and then I'll change the drill point to flat. I'll click OK to exit the hole command, and we are now officially done with the handle of our screwdriver. At this point, we'll want to create a new component for the shank of our screwdriver. But first, we'll want to activate the top level component so our new component is nested within it. To activate it, I'll click on the little circle to the right of our file name. And once activated, I'll select New Component from the Assemble drop-down list. And I'll rename this one Shank and click OK. Now you'll see in the Fusion 360 browser that the shank and handle components are nested underneath the screwdriver assembly. I'll make sure that the shank component is active before we start doing any work, and then I'll select the face of our hole. This way, if we change the hole dimension later on, our shank dimension will update accordingly, just like we talked about in day number 13. I'll hit letter E for extrude, and then I'll make the distance 150 millimeters and click OK. Now let's click on the circle next to the handle component to reactivate it, and we'll take a look at our hole size. I'll double click on the hole feature and change the width to 10 millimeters and then click OK. Then I'll reactivate our assembly, and you'll see that the width of our shank did update accordingly as we expected. I'll go ahead and click undo to revert back to the original size. Now all we have to do is create our screwdriver tip, which we'll create a new component for. This time I'll use another method. I'll right click on the top assembly and select new component. I'll double click on the component in the browser and type in tip for the name. I'll select the front face of the shank and click letter E on the keyboard for extrude, and I'll punch in 10 millimeters for the distance. I'll make sure new body is selected, and then I'll click OK. And before I forget, I'll find the body in the browser and rename it to slot head tip. Now we're going to create the slot or flathead tip by cutting at the cylinder from the side. I'll right click on the YZ plane and select Create Sketch. Then I'll activate the 3-point arc from the Sketch drop-down list. For the first point, I'll select the front edge here where it snaps in place. I'll select the top line where it snaps in place, and then I'm just going to put the third point where it creates that nice arc of the flathead. Now at this point, we'll want to fully define our sketch so we don't mess it up if we change dimensions in any of our other components. I'll hit letter D to activate the dimension tool. I'll click on the end of the 3-point arc here. I'll click on the center origin of our tip, and I'll make this 0.5 millimeters, and then hit the escape key to exit. Now you may have noticed that the other endpoint moved down. So I'll select this endpoint of the arc, and holding down Shift, I'll select the corner of the cylinder. Now I'll click on the horizontal constraint icon. This way, it's always in line with the thickness of the tip, even if we change our dimensions. Now in order to extrude cut this shape, we'll have to close off our profile. So we can hit letter L for line and then draw a horizontal line. And we can also draw a vertical line connecting the endpoints. Once again, before we cut this, we'll also want to make sure that all of our lines are black, indicating that they are fully constrained. Using D on the keyboard for dimension, I'll select the horizontal line and I'll make this 9 millimeters. Then you'll notice that the arc is still blue because we can dimension the radius of it. So we'll click on the arc and then hit enter. And you'll see after that, our profile is fully constrained as it has black lines all the way around. I'll hit letter E for extrude, select the profile, and I'll change the direction here to 2 sides. We'll need to change the operation to cut, and for the extent of each side, we'll select all. Now the reason we're selecting all is again for the purposes of our dimensions. If we decided to make this shaft thicker, then our cut here will update accordingly, and we won't have to go back and manually edit this extrude feature. I'll click OK to exit the extrude command, and now we'll want to select mirror from the create menu. We'll change the pattern type to features, and we'll select the extrude in the timeline. For the midplane, I'll select the XZ plane in the browser, and then I'll click OK to take a look at the results. Now we're essentially done with our slot head screwdriver. We can reactivate the top level component to take a look at it. And of course, we can always select a component, hit letter A for appearances, and we can drag and drop the appearances onto each component. In Fusion 360, the timeline is that lower bar that captures your design history. To demo some timeline tips in this video, I'm going to use the screwdriver that we 3D modeled in day number 14. I'll put a link to that video in the video description. The first timeline tip is that you can play back the design history. Now, as you're learning Fusion 360, this can be a great way to learn from someone else's design. All you have to do is click the play button to the left of the timeline, and you'll see that it will instantly start walking you through each step. You can also click on the previous step button to go back to the previous step, the move to beginning button to go all the way to the beginning, the next step button to go to the next step, or the move to the end button to quickly go to the end of the timeline. I can also simply drag this slider around, which is referred to as rolling back the design. Or I can right-click on a timeline feature and select Roll History Marker here, which will automatically place the marker at that feature. The second timeline tip is that you can turn on the component color swatch under the timeline options in the right-hand corner here. This will label all of the features in your timeline per their component. And if I go to the Inspect menu and turn on the Component Color Cycling toggle, you'll see that it will color the components to further help us see what features relate to each component. It's also important to note that it added the same color in the Fusion 360 browser. And if I click to activate a component, you'll see that the features in the timeline are isolated to only show features pertaining to the activated component. The third timeline tip is that you can right-click on a feature in the Fusion 360 timeline and select Find in Browser. And you'll see that it will highlight the related features in the browser with these dashed lines. Now, this is particularly helpful in a very large assembly file where the timeline may take up your entire screen. You can also do the opposite and right-click on an object in the browser and select Find in Timeline. And you'll see that the timeline features are also highlighted with dashed lines. The fourth timeline tip is that you can suppress features and make them temporarily unavailable. To suppress a feature, simply right-click on the feature and select Suppress. Now, suppress features do not display in the graphics window, and they will be dimmed in both the browser and the timeline. You'll notice that if I suppress the beginning of a feature that has others dependent on it, then it will suppress all of the dependent features. Or I can select a feature or occurrence that has nothing depending on it, and it will only suppress that one feature. The fifth timeline tip is that you can create groups to further organize your timeline, which can be helpful if your timeline is very long with a large assembly file. Now, to group timeline features, I will hold down Command on Mac or Control on Windows and select all of these fillets. Then I'll right-click and select Create Group. You'll see that it will immediately group the features, and you can toggle the group open and closed by clicking on the plus or minus icon. I can also right-click on the group, select Rename, and rename this group to Fillets. Now, if you want to delete the group, you can select the group, hit the Delete key, and then make sure you're only deleting the group and not its contents. Unless you do want to delete everything, you can select that option as well. Now, the sixth timeline tip is that you can right-click on an individual feature and rename that, similar to how we can rename groups. If I right-click on the first fillet, I can rename this front of handle, which may help me later on if I were trying to find this specific fillet. Now, this really depends on your workflow and personal preference, as you can always select features in the timeline and look at the corresponding highlight in the graphics window. The seventh timeline tip is that you can create selection sets. Now, a selection set is a way to select a number of different components or features in a complex assembly, in which you don't have to keep selecting them one by one. Selection sets can help you spend less time selecting and more time focused on designing. Now, to create a selection set, I'll simply hold down the Command key on Mac or the Control key on Windows, right-click on one of the features, and select Create Selection Set. Now, I could also do the same by selecting multiple components or bodies in the Fusion 360 browser. Then you'll notice in the browser, these selection sets will be grouped in a folder. And you can click on the selection icon to quickly select all of its objects. You can also right-click on the selection button and you'll have a number of options. So again, this selection set really only becomes useful in very large assemblies and files, especially if you need to keep selecting components or features to suppress them or make any other changes all at once. The eighth and final timeline tip is that you can drag features around to fix errors in your model. Probably one of the most common errors occurs when using the shell feature. If I take a look at this other example, you'll see that it shelled this box out. Now, if I wanted to add a fillet to the corner, it's going to ruin the box and it will no longer have a solid edge all the way around. To fix this, I can simply click and drag on the fillet and release it before the shell command, and you'll see that now the shell is applied after the fillet, which fixes the model. Now, keep in mind that moving features around is kind of a last resort. I highly recommend sketching out your designs before working in Fusion, which will allow you to think about these sort of things before they happen. Otherwise, you'll find that sometimes sliding these timeline features around can cause more errors than it fixes.